Hello friends, I am Balaji Rao. Welcome to BR Max class. This is first class on Principle of Mathematical Induction. In this class, I explained clearly what is the basic idea behind Principle of Mathematical Induction. I did 3 problems in this class. It's around 30 minutes video. You please concentrate on those 3 problems. If you understand first 3 problems in this chapter, you can understand almost all the problems in this chapter. Let's begin. Hello friends, I am Balaji Rao. Welcome to BR Max class. Before going to know the definition of Principle of Mathematical Induction, we need to discuss few examples. How many of you knows how to cook the rice? A task is given to you to cook the rice. Once the rice is started cooking, when you identify that the rice is ready to eat, generally what we do, we take one rice piece and we'll press it. If it is boiled, good. Then what we do? We'll take the second piece and we'll press and we'll check whether it is boiled or not. Next we'll take the third piece and we'll check it whether it is boiled or not. Next we'll take the fourth piece. We'll check whether it is boiled or not. That is the procedure to check the rice is cooked or not? No, not at all. What we do, first we take one piece of rice and we'll press it and we'll check whether it is boiled or not. If it is boiled, we'll assume that all rice pieces are boiled. Still, to get the confirmation, we'll take one more piece and we'll check whether it is boiled or not, correct or not. No one will check by pressing all the rice pieces and they'll check each piece is boiled or not. That is not the procedure, correct or not. So this principle of mathematical induction is also like that only. What I am trying to say, to cook the rice, we do not check that all the pieces by pressing whether they are boiled or not. At particular point, we'll take one rice piece and we'll check whether it is boiled or not. If it is boiled, we assume that all rice pieces are boiled. Still, to get the confirmation, I'll take one more piece and I'll check whether it is boiled or not. If it is boiled, it means that the rice is ready to eat. And I'll give one more example here. After that, I'll come to the definition of Principle of Mathematical Induction. You observe this question. This statement says that sum of first n natural numbers is n into n plus 1 divided by 2. I'm just trying to discuss few things before learning the definition of Principle of Mathematical Induction. You see here, n equal to 1. n equal to means sum of 1 terms. You take only 1. In RHS also you put n equal to 1. What you got here? 1 equal to 1. That means this statement is true for n equal to 1. Next, I'll take n equal to 2. n equal to 2 means sum of 2 terms. You see here, sum of 2 terms, 1 plus 2. What is 1 plus 2? 1 plus 2, in right hand side also, in place of n, I kept 2. What happened? I got 3 equal to 3. That means this statement is true for n equal to 2. n equal to 3 means sum of first 3 terms. You can observe here, I written 1 plus 2 plus 3 from left hand side, and in the right hand side, in place of n, I written 3. Then you see what I got? I got 6 equal to 6. Similarly, I consider n equal to 4. That means sum of first 4 terms. In RHS also, I put n equal to 4. What I got? I got 10 equal to 10. Next what? N equal to 5. Next what? N equal to 6. That is the way to prove this statement? If I started proving like this, n equal to 4, n equal to 5, here, n is a natural number. If I started proving like that, when this problem is going to complete. So, to prove this type of statements, Principle of Mathematical Induction is very useful. Now we will understand what is Principle of Mathematical Induction. Whatever the statement we are trying to prove, we take that statement as P of n. First, we take the given statement as P of n. Then we will try to prove 2 things. First one, P of 1 is true. P of 1 is true means we are trying to say that this statement is true for n equal to 1. Once we proved that P of 1 is true, by assuming P of k is true, we prove that P of k plus 1 is true. If we can prove these 2 statements, then P of n is true. Whatever the statement is there in this red box, this statement is known as Principle of Mathematical Induction. Now, you can easily remember this with the example of cooking rice. What is P of n? P of n is cooking rice of n pieces. First, we'll prove that P of 1 is true. We'll take one piece of rice and we'll press it and we'll check whether it is boiled or not. If it is boiled, it means that P of 1 is true. Then what we assume? We assume that all k pieces are boiled. Correct or not? We assume P of k is true. To get the confirmation, I'll take one more piece and I'll check whether it is boiled or not. Taking one more piece is nothing but like k plus 1. P of k plus 1 is true. Once these two conditions are true, then we say that P of n is true. Actually, cooking rice is one of the best example to understand what is this principle of mathematical induction. Finally, we will conclude about this definition. There are few statements which cannot be proved at each and every point. For example, cooking the rice. No one will check by taking each piece whether the rice is boiled or not. You will do that? No, no one will do that. What we do, in the process of cooking rice, we will take one piece of rice and we will check whether it is boiled or not. If it is boiled, we'll assume that all rice pieces are boiled. To get the confirmation, we'll take one more piece and we'll check whether it is boiled or not. If that piece is also boiled, it means that rice is ready to eat. Like that, what is principle of mathematical induction? Whatever the statement you are trying to prove, you take that statement as P of n and you prove that P of 1 is true. Once P of 1 is true, you assume that P of k is true. From that, you prove that P of k plus 1 is true. Once you prove these two things, principle of mathematical induction says that the given statement P of n is true. You see this question, what they are asking. Prove that 1 plus 2 plus 3 plus and so on plus n equal to n into n plus 1 by 2. Here n is a natural number. We need to prove this by using principle of mathematical induction. First thing, which statement you are trying to prove, that statement we will take it as P of n. You observe here, I considered given statement as P of n. You need to prove two things. First one, you prove that P of 1 is true. How to prove the statement is true for n equal to 1? LHS I'll consider as n. Here we are trying to prove that this is true for n equal to 1. So in this, in place of n, I'll write 1. So what I got LHS? LHS is 1. Now I'll take RH. In this statement, what is RHS? RHS is n into n plus 1 divided by. In this, wherever n is there you write 1. What you will get? 1 into 1 plus 1, 2 divided by 2. So this is nothing but 2 divided by 2. That is 1. LHS is 1. RHS is 1. It says that this statement is true for n equal to 1. That means what we will write here? We will write that P of 1 is true. Actually, we need to prove two things. First one, P of 1 is true. That is over. First step is over. Now second step. What is the second step? You assume P of k is true. By assuming P of k is true, you prove that P of k plus 1 is true. P of k is true. What is P of k? We know P of n. P of k means in this statement, wherever n is there you write k. So I'll write P of k. What is P of k? 1 plus 2 plus 3 plus and so on plus k. In this P of n, wherever n is there you write k. Then you will get P of k equal to k into k plus 1 divided by. So this is P of k. You assumed that this is true. We are assuming that this is true. By using this information, you need to prove that P of k plus 1 is true. Now, I'll write a key step here. In all the problems of principle of mathematical induction, at this point means after writing P of k, we will add a term on both sides. That term you need to identify. What term we'll add on both sides? This is like a key step. Key step means what? For example, your house is locked. If key is there with you, then you can easily enter. If key is not there, then it is very difficult to enter. Correct or not? Here, if you know this, it is easy to do this problem further. This is important step. What is that term? How to find out that term? You see this P of k. You observe this. What term is there here? Here k is there. In this term, wherever k is there you write k plus 1. This is not only for this problem. For all the problems, we will follow the same procedure. Here, at this point, in this term, where k is there you write k plus 1. What you got here? You got k plus 1. So you add that term on both sides. Adding k plus 1 on both sides. Actually, what is your intention? Your intention is, by assuming P of k is true, you are trying to prove that P of k plus 1 is true. We are trying to prove that P of k plus 1 is true. Okay. You see, what is this statement? This statement is P of k. What is P of k plus 1? in this statement, wherever k is there, there you write k plus 1, you will get p of k plus 1. K plus 1 into here k plus 1 plus 1. In place of k, you write k plus 1. K plus 1 plus 1. That is what? That is k plus 2 whole divided by 2. Okay. What is this? P of k plus 1. Now we are trying to prove that p of k plus 1 is true. What is p of k plus 1? This statement is p of k plus 1. We are trying to prove this. Okay. 1 plus 2 plus 3 plus and so on plus k. See, after this step, I am adding k plus 1 on both sides. K plus 1, adding k plus 1 equal to k into k plus 1 divided by 2 plus k plus 1. What happened? After this step, I added k plus 1 on both sides. Now, what we are trying for? We are trying to prove p of k plus 1 is true. I am trying to prove this statement. You see, 1 plus 2 plus 3 plus and so on k plus 1. You look here. 1 plus 2 plus 3 plus 4 plus and so on plus k plus 1. What is this left hand side part? You observe this. What is this left hand side part? This is LHS of p of k plus 1. I am trying to prove p of k plus 1 is true. I am trying to get this statement. Now, what we needed here, I'll simplify this part. After simplifying this part, if I got this statement, I can say that p of k plus 1 is true. Okay. So, what I'll do, I'll start simplifying. See, what is this left hand side part? It is LHS of p of k plus 1. After simplifying this, I am trying to get RHS of p of k plus 1. Okay. What is LCM here? LCM is 2. What you will get in the numerator? K into k plus 1 plus 2 into k plus 1. Good. Here also there is a small tricky thing. You do not multiply with k. You see, in this term, k plus 1 is there. In this term also k plus 1 is there. You just take k plus 1 common. Okay. You just take k plus 1 common. Okay. You taken k plus 1 common. Now, here what is remaining? Here k is remaining. Here what is remaining? Here 2 is remaining. Correct? Whole divided by 2. Right? You see here, we are trying for RHS of p of k plus 1. We got the same thing. You can observe this here. So, what happened? 1 plus, 2 plus, 3 plus, and so on plus k plus 1. No need to write k here. Before k plus 1, obviously k will be there. What is this? We assumed this is true. We assumed this is true. After adding a particular number on both sides, whatever you will get, that is also true. That means this is true. What is this? This is p of k plus 1. Therefore, p of k plus 1 is true. What is this? This is p of k plus 1. P of k plus 1 is true. I hope you are understanding. Therefore, what happened? What happened? We proved two things. First, we proved that p of 1 is true. Next, we proved that p of k plus 1 is true by assuming p of k is true. So, therefore, by principle of mathematical induction, p of n is true. 1 plus, 2 plus, 3 plus, and so on plus n equal to n into n plus 1 divided by 2 for all n belongs to n. So, we proved this statement by using principle of mathematical induction. This is the first problem. That's why I took time to explain all the things in detail. See here what is happening exactly. First, what statement we are trying to prove, I taken that statement as p of n. And then I proved the statement is true for n equal to 1. After that, I assumed that p of k is true. After assuming p of k is true, we will write what is p of k. And then we'll add a particular term on both sides. This is the key step. How to get this key step? In this p of k, at this kth term, wherever k is there you write k plus 1. What term you will get, you add that term on both sides. After doing this step, what happens? Whatever is there left hand side, that will be LHS of p of k plus 1. You always keep what is p of k plus 1 in your mind. So, this is LHS of p of k plus 1. After simplifying this, whatever you got here, you can observe that that is RHS of p of k plus 1. So finally, p of k plus 1 is true. As we proved p of 1 is true, and by assuming p of k is true, we proved p of k plus 1 is true. By principle of mathematical induction, we can say that p of n is. You see this second problem. Prove that 1 square plus 2 square plus 3 square plus and so on plus n square equal to n into n plus 1 into 2n plus 1 divided by 6. We need to prove this statement by using principle of mathematical induction. First, which statement we are trying to prove, we will take that statement as p of n. You observe here, I considered given statement as P of n. After considering given statement as P of n, we need to prove two things. First one, P of 1 is. To prove P of 1 is true, I considered n equal to 1. So, how to prove P of 1 is true? First, you take left hand side part. In this, you take this n square. Okay, nth term. In this, you see this nth term, n square you take. In place of n, you write 1. What you will get? 1 square. 1 square is 1. Now, I'll calculate RHS. Now, I considered RHS of this statement. In this also, I'll put n equal to 1. We will see what happened. 1 into 1 plus 1. 2 into, in place of n, you write 1. 2 into 1, that is 2. 2 plus 1 is 3. Whole divided by 6. 1 into 2 into 3, that is 6. Divided by 6. 6 divided by 6 is 1. What happened? LHS value we got 1, RHS value we got 1. So what you can write? So LHS equal to RHS. We got this LHS equal to RHS when n equal to 1. It tells you that P of 1 is true. Once we prove P of 1 is true, second step is you assume P of k is true and prove that P of k plus 1 is true. You assume that P of k is true. First, I'll write what is P of k. See here, in this P of n, P of n, P of k. In this statement P of n, wherever n is there you write k. Then you will get P of k. This is P of k. How I got this statement? In P of n, wherever n is there you write k. Then you will get P of k. In almost all the problems, after this step, we will add a term on both. That is the key step. What term we will add on both sides? You observe P of k. You see this term, kth term. What is there? K square is there. In that term, wherever k is there you write k plus 1. What? In place of k, if I write k plus 1, this will become k plus 1 whole square. So, this term k plus 1 whole square we need to add on both sides. Adding k plus 1 whole square on both. You see, what happened here? I added k plus 1 whole square on both sides. Actually, what is our intention? After assuming P of k is true, we are trying to prove that P of k plus 1 is true. I'll write what is P of k plus 1 at the margin. Okay, you see this statement. You see this. What is this? P of k plus 1. Actually, what is our intention? We are trying to prove P of k plus 1 is true. So, after adding that term, after adding a particular term on both sides, whatever you will get here, that is LHS of P of k plus 1. Now, what is our intention? This right hand side part you observe. After simplifying this, if I get this statement k plus 1 into k plus 2 into 2k plus 3 divided by 6, then I can say that P of k plus 1 is true. So, I'll simplify this right hand side part and I'll try to get this. If I take the LCM, what LCM you will get here? 6. What is there in the numerator? K into k plus 1 into 2k plus 1 plus 6 into k plus 1 whole square. Okay. Now, you observe the numerator part. In first term, k plus 1 is there. In second term, also k plus 1 is there. So, we can take k plus 1 common. So, you take k plus 1 common in the numerator. If you take k plus 1 common in the numerator, what is remaining? K into 2k plus 1 plus 6 into, if you take k plus 1 common, here one more k plus 1 is remaining. 6 into k plus 1 whole divided by 6. Okay, that equal to k plus 1 into, you just simplify this, k into 2k, that is 2k square plus k into 1 k plus 6 into k 6k plus 6 into 1 6 whole divided by 6. Okay, now if we simplify this further, k plus 1 into, see here 2k square k plus 6k, that is 7k plus 6 whole divided by, what is our intention? After simplifying this, what you are trying to get? This expression must be of this k plus 1 into k plus 2 into 2k plus 3 divided by 6. You can see here k plus 1 we already got. Now what I'll do, this is the quadratic expression. I'll simplify this in the margin. We will see what we will get. 2k square plus 7k plus 6. You split the middle term by writing it as a 4k plus 3k. 4k plus 3k is 7k plus 6. Now in first two terms, in these two terms you take 2k common. If you take 2k common, what you will get? You will get k plus 2, okay, plus in these two we can take 3 common, then what you will get? K plus 2. So in this term also k plus 2 is there, here also k plus 2 is there. You take k plus 2 common. If you take k plus 2 common, what is remaining? Remaining one is 2k plus 3. So what you understand? You understand that 2k square plus 7k plus 6 can be written as k plus 2 into 2k plus 3. So in next step I will do the same thing. K plus 1 into 2k square plus 7k plus 6 can be written as, yes, k plus 2 into 2k plus 3 whole divided by 6. What is this? This is RHS of P of k plus 1. See here, k plus 1, k plus 1, k plus 2, k plus 2, 2k plus 3, 2k plus 3. Right? So this part, left hand side part, what is there? 1 square plus 2 square plus 3 square plus and so on plus k plus 1 whole square. See this, k plus 1 whole square. Okay. So what I will try to say now, listen this carefully. We assumed this is true. We assumed this is true. For an equation, if you add a particular term on both sides, whatever you will get, that is also true. That means this is true. This side, I did little bit of simplification. Whatever you got here, this is true. Actually, what is this? In place of k, if you write k plus 1, you will get p of k plus 1 now. What is this? You observe, what is this? This is p of k plus 1. Therefore, p of k plus 1 is true. What is the conclusion? By principle of mathematical induction, what I can write? I can write that p of n is true. So finally what we proved? We proved that 1 square plus 2 square plus 3 square plus and so on plus n square equal to n into n plus 1 into 2n plus 1 divided by 6 for all n belongs to n. Okay, you see this third question. Prove that 1 cube plus 2 cube plus 3 cube plus and so on plus n cube equal to n square into n plus 1 whole square divided by 4 for all n belongs to n. We need to prove this statement by using principle of mathematical induction. So what is the first step? We will take given statement as p of n. I considered given statement as p of n. Now we need to prove two things. First one, p of 1 is true. You see how we prove p of 1 is true. For n equal to 1, first we will take LHS. How to calculate LHS? In this term, in this LHS part, you observe this nth term. You take that one. And in place of n, you write 1. 1 cube. What is 1 cube? 1 cube is 1. Now you take RHS. What is RHS? RHS is n square into n plus 1 whole square divided by 4. In this, wherever n is there, there you put n equal to 1. What you will get? 1 square. 1 square is 1 into 1 plus 1. 1 plus 1 is 2. 2 square divided by 4. That is 1 into 4. 4 divided by 4. That is 1. LHS is 1. RHS is also 1. Don't think that every time we will get LHS 1, RHS 1. For the last 3 problems, luckily we are getting LHS equal to 1, RHS equal to 1. So here, what you can write? You can write that LHS equal to RHS. This is happened for n equal to 1. So what I can write here? I can write that p of 1 is true. So first part is completed. Now second one is what? We will assume p of k is true. From that we will prove that p of k plus 1 is true. Assume p of k is true. Now I will write what is p of k. In p of n, wherever n is there I written k, then I got p of k. This is p of k. In almost all the problems, after writing p of k, we will add a term on both sides. Here, what term we will add? We will add a term on both sides. What term we will add on both sides? You see here, what is there here? K cube is there. Kth term is what here? Kth term is k cube. Right? In this, wherever k is there you write k plus 1. Then what you will get? You will get k plus 1 whole cube. In this, in place of k, if I write k plus 1, I will get k plus 1 whole cube. That term we will add on both sides. See, I am adding k plus 1 whole cube on both sides. See, I added k plus 1 whole cube on both sides. Actually, what we are trying for? By assuming p of k is true, we are trying to prove that p of k plus 1 is true. You see here, this is p of k plus 1. How you got p of k plus 1? In p of k, in place of k, if you write k plus 1, you can identify what is p of k plus 1. Now our intention is we are trying to prove p of k plus 1 is true. After adding this particular term on both sides, whatever you got here, that will be LHS of p of k plus 1. That will be LHS of p of k plus 1. What is our intention now? By simplifying this part, you are trying to get RHS of p of k plus 1. That means you are trying to get this one. So you just start simplifying this. Here 4 is the LCM. Then what you will get in the numerator? K square into k plus 1 whole square plus 4 into k plus 1 whole. It do not multiply these things. You see, in this first term k plus 1 whole square is there. In this second term also k plus 1 whole square is there. So in the numerator you take k plus 1 whole square common. If you take k plus 1 whole square common in the numerator, what is remaining here? Here k square is remaining. Plus, if you take k plus 1 whole square common, what is remaining? 4 into k plus 1 whole divided by 4. That equal to k plus 1 whole square into k square plus multiply with 4. What you will get? That is 4k plus 4 whole divided by 4. That equal to k plus 1 whole square into k square plus 4k plus 2. K square plus 4k plus 2. You can easily understand that is k plus 2 whole square expansion. Expand k plus 2 whole square, a square, that is k square, b square plus 4 plus 2ab, 2 into k into 2, that is 4k, divided by 4. You look here, what we got? We got k plus 1 whole square into k plus 2 whole square divided by 4. So what is this LHS part also I will write? 1 cube plus 2 cube plus 3 cube plus and so on plus k plus 1 whole cube equal to k plus 1 whole square into k plus 2 whole square divided by 4. What is this statement? This statement is p of k plus 1 that we can observe here. What happened? We assumed p of k is true. This is true. We assumed this is true. After adding a particular term on both sides, whatever you will get, that is also true. That means this is true. After doing a little bit of simplification, I got this statement. What is this? This is p of k plus 1. That means p of k plus 1 is true. Therefore, p of k plus 1 is true. As we proved p of 1 is true, and by assuming p of k is true, we proved p of k plus 1 is true. So from principle of mathematical induction, we can say that p of n is true. What is p of n? 1 cube plus 2 cube plus 3 cube plus and so on plus n cube equal to n square into n plus 1 whole square divided by. This class is important. If you understand these three problems, remaining all the problems in this exercise are of same model. So have patience, and one more time you practice all these problems, then rest of all exercise is very easy.